This conference will now be recorded. This conference will now be recorded.
Yeah, let's see what else we got here. Alrighty, just kind of checking through here.
Where do we put our company name, Don? I'm trying to figure out.
If you click on the hamburger,
yeah.
When you click on that little hamburger, you should see edit your name and email, like the fifth line down. Do people know what I'm talking about when I say the hamburger? Second here. I'll see if I can do something. Gonna get tricky here. Tricky real quick. That didn't work.
Got it.
So I'm going to go ahead and start real quick, and we'll move on. When I say start, expect people strolling in. Again, this is the Advanced Cooling Facilities. The mission is to develop best practices, collaboration documents, common guidelines, facilitating liquid cooling integration into data centers. The hashtag Don't Fear Liquid Cooling, but Plan for IT or Plan for It is kind of our hashtag motto, if you will. Real quick review, we are not looking to necessarily promote liquid cooling. Obviously, we're doing that, but we're really, we have other groups that will promote. There's actually other sub-projects that are associated with OCP that look at immersion and cold plate and door heat exchangers. We're actually under the data center facility sub-project. I would encourage people to not only go to this webpage. One of the other things I'm also doing is I'm going to try to reduce the number of double invites that we have. And double invites occur when you are signed up for the OCP mailing list, and I send you an invite as well. And so I'll be going through, and people will see them getting rejected or meetings canceled because I'm going to take names off of the custom invite list. And actually, if you're already on the OCP mailing list, I'm going to try to reduce the backlog of stuff that's popping up in your inbox. And just so you know, that's fairly simple to do. You can go to the OCP webpage, Advanced Cooling Facilities. And if you go in here, you can subscribe to mailing lists. If you subscribe to mailing list, I'll check you off on the mailing list, and I'll pull you off my open invite thing. A lot of people have told me they can't always make the meetings, but they do want to be kept on there. And correspondingly, I don't want to be spamming people with more emails than they need. Any comments on that? We'll hand this back here. I would like to make sure John Minash gets a chance to talk. We're going to kind of go through some of the agenda for today, but so we covered the mailing list sign up. We identified on your calls. John, you want to chat a little bit about this concept of call for papers and published by September? What does that mean?
Yeah. So, Don, if you could give me the screen to share for a moment here, I will do that.
Hold on a second here. You should have it.
Yeah, great. Okay. Sorry, let me get all this.
Ooh, that's very nice.
All right, so this is just a rough idea of what I think we should put some dates down for completion on. What I'd like to focus on is the appendices, which are a big part of our papers here. This is not addressing the papers themselves, but the appendices, which again are a pretty big part. This is today. We'd like to target the end of September for getting these papers out. So at the end of the summer, and these are the actual appendices that we've got identified right now for the two papers. So in the connections guidance paper, connections and reference designs paper, we've got 30 connections, commissioning couplings, commissioning flanges, commissioning welds and fuse connections, and then operating procedures, MOPs, SOPs.
I'm laughing, John, because I actually made some changes this morning. So obviously you've been working pretty fast on this.
And then we've also got the reference design and general guidance paper. And that one has effectively the BIM recommendations from us. And now we don't have a repository yet identified for where we keep anything, but that'll be hopefully part of this one. Cooling distribution systems, so CDUs, keys to loops, and that's related to water and others. Cleaning the waters, and then risk analysis, the FEMA topic. So there's really 10 items that will be considered appendices in their own. I would like to start, not this week, but next week, bringing them up. We'll show what we have. Ask for, I'm going to ask for contributors today and ideas and people, but next week I'd like to open it up, and we'll spend, let's say, 20 minutes of our time of the meeting going through these individual items and seeing if there's any feedback, problems, issues, what have you. So I'm calling this evaluation. And then we'll eventually get to the point where towards the end of July, we'll have all of the ones for the connections paper done. And then we'll spend a week, we'll just approve them all 1 week. So that same 20 minutes we'll just spend going through and seeing if there's agreement. Then we'll do the same thing towards the latter part of the summer, going through the reference design papers and then get approval. Ultimately, towards the end of that, there's going to be some work for myself and Don to go through and get everything, grammar, citations, all the things that make a paper proper. And then want to get it out to the DCF leadership at the end of September. That's my proposed schedule, and so that we can actually put some milestones down. We've been fairly open, and just the documents are there, and they are editable by anybody that's on this call today, and that will continue. We hope you'll join in and just, even for just grammar, go through there and give us some feedback. But if you see something that's phrased oddly, or if you can think of a good graphic, you can add it. You can send it to us. What I would ask is, if you have anything that you're going to add that's work from someone else, please try to provide the citation as to where it came from, because that's going to have to be finalized properly in publishing format, like an AMA format, so that we can reference these things going forward. And that's true of both articles, graphs, but graphics too, pictures. If there is a way to reference those. So if you can provide us a link, we can always track it down. But if you can give us that, will be good. So that's it. So starting next week, I'd like to, Don, probably take maybe the first 20 minutes after you do your intro of these meetings, and spend a little time on these individual appendices for this. Does that sound kosher?
That sounds good to me. Other people have questions, probably a better thing. Any questions or comments on this?
I don't see any text chats. All right. Well, I will put this up at, I'll convert this to a a Google document so that we can share it, and it's up on our webpage here. But that's the intended schedule as at present. Okay, that's it, Don. So you can take it back.
Okay, hold on a second here. Let's see, how do I take it back? You have to give it to me. I'll just take it. I'm going to share real quick.
Maybe so.
So kind of moving through a couple things. I will be reaching out to people that I feel need to be contributors to this. And for example, there was a white paper that was published by, hold on a second here. Hopefully I still have it on my screen. Yeah. So there's a section here, and there's other groups. And this white paper here was published recently, Leak Detection Intervention. And I'm going to be reaching out, for example, to these people and asking them to be contributors to our articles so that it integrates with their white paper. There is an overlap here on leak detection intervention that is primarily targeted around the cold plate. And actually, I don't know, Cam Turner's not on this call, but we've got a couple other people from Cool IT. Is there anyone on Cool IT that is aware of the contributions in this? You can run, but you can't hide. I'm going to find you pretty quick if you don't speak up.
Hi, Dawn. Yes, we're aware that Cam is working on this contribution here with his team.
Okay. Well, one of the key things is Open Compute is a large organization. We cover not just, from my world, I just look at advanced cooling facilities, but for this program to be successful, we need to link with the other white papers. So rather than us spend an exorbitant amount of time on talking about leak detection intervention, which is part of what we'd be looking at reference designs, I'm going to try to pull in the people and the authors of this paper as being contributors to our papers, so that we look cohesive, that we're messaging the same thing the same way. And there's some great examples of how to use leak detection in this paper here. The other thing I'd also be doing, Michael Gonzalez and others that are associated with the connector. Michael, you're with Shane? Give me a wake up there. You're on mute right now if you're trying to talk. There you go.
Correct, Don, with Sane Industrial.
Okay. So I would love to have contributions. There's some areas on, for example, on threads. We're looking at building an appendix that's talking about threaded connection standards. And fundamentally, I see threads as either being used, well, I guess the question is, I would think in your perspective, what's your perspective on threaded connections in terms of, do they leak? How do you keep them from leaking? Things of that nature.
And I assume you're speaking about under 2 inches, kind of what we talked about in our previous meetings.
Exactly. Because my perspective is, in many cases, your devices would thread into something. So obviously you have, of the people on this call, you might have as much interest in how to properly connect the thread as anybody. Is that a fair assumption, or what are your thoughts?
Correct. Yeah, there's definitely the guidance that we give, to our customers, not only on the thread, but also on maybe, how the threaded, how it's actually screwed into their application based on how it's actually connecting and things of that nature.
Okay, so I don't want to, this actually does lead into one of the topics I wanted to cover today, and I was going to start with this one first and kind of move backwards. So if we go to the connection guidance white paper, and we open that up, and this is, it's on link, everyone should have access to it. I send these work streams out. But if you go all the way down to the appendix section, and one of the problems I will say is doing this online, there's always a lag when you're trying to do this at the same time you're presenting. We'll see if I can get down here. But if we go down to the section at the bottom, and see, here's what I was talking about before. There was a little comment in there on leak detection, which is very much associated with the connection section. But as we get to this part here, Appendix A doesn't say squat right now. It just has a picture of what a thread connection is. But I'd love to have Parker and Sane and others take a look at this and come up with, if anything, a summary of why we came up with metric, okay, versus all the other threads. And your input would be huge. If the question of whether or not we can work with metric on a global basis, to a large extent, depends on whether or not people have access to that, and your weigh in on that would be huge. But then also, if you were to write up a description on this is a best practice on how to put together a threaded connection so it doesn't leak, that would be huge as well. Let me ask you that, kind of going back to this. Do you see threading connections as being something that can be verified as something that will never leak?
I mean, ideally, yes, if they're within, the design parameters and everything runs smoothly. So we know how that goes. But I mean, yeah, there's definitely some guidance that we can give. And I think it'd be good if we all work together. I'm pretty sure that a lot of the other QC vendors, we all have some similar guidance that we give, and we all have probably one, if not all, of the same thread types. We may have some preferences across different companies, but I definitely think it's something that we could put in an appendix and make it really simple for someone to look at and quickly understand and gauge when they're talking about threading.
Okay. So the other question, kind of revisiting something that I think we've answered, but it still needs to be answered, is do you feel comfortable with, I mean, will there be a supply chain, a global supply chain issue if we standardized on metric? Is that or do you feel that most of yourselves and your supply chains around the world would be able to deliver metric products?
It's kind of depends on the company. It may not be fair for me to say yes or no, and it may be something, it depends where, Sane's a global company. I know Parker's a global company, but it may depend on where they're being manufactured and what that standard is. I know that our website our US website has, inches, but then everything is pretty much in metric, because it's a Swedish company. So it's really not too much of a big deal for us. It's something I'd prefer, and we usually prefer anyway, but it may be good to discuss that a little more just to make sure that everyone is comfortable with that. I don't know if I have any other,
Yeah, no, and so the one thing I would consider is I'd love to have, you and do we have anyone from Parker on the call today? I know a lot of times we have, but if we get a couple companies that, what? Go ahead.
Yeah, just a comment, Rolf here, ICS immersion. So within all the ICS work groups, we have all defined the metric system to be leading for us. So on the ICS side, everything is standardized on metric.
Okay. So again, one of the things
inside.
When we put out these documents and these white papers with recommendations, the recommendations aren't expected to be snapped overnight. But if the world, as they move toward liquids in data centers, if they recognize that is going to be the goal, then we kind of would expect that on a global basis, the quick connector entities that want to move in the right direction would either speak up now or just kind of commit to doing metrics someday in the future where they see wanting to be active in liquid distribution of data centers. So that's kind of the conclusion here. There has to be a little bit of confinement, but does anyone feel like we're railroading people here? Does this sound consistent with what the industry needs to do?
Fine on my end. On behalf of Sane, it's not an issue. I prefer metric, and I know that we offer in metric.
Okay. So we're going to move on to another. Go ahead.
I think it's the right thing to do, and it is something that we should be moving towards. But I think that if you gathered, say US users. I'm thinking specifically, say, of the national labs that use a lot of liquid cooling. We have, it's official government policy to move to metric, but I can tell you from a practical standpoint and a spare parts and a maintenance standpoint, it's a problem. So, you may want to have a little focus group of actual users, specifically non-international users, and just get their buy-in. Again, I think most people agree it's the right thing to do, but there's also the practical side.
Well, and again, one of the things I'd like to highlight is we're not saying everything in the world needs to be metric, okay? We're just saying that products that are associated with liquid cooling in terms of the connection point to a door heat exchanger or the connection point to a immersion tank or the connection point to a cold plate will use a metric standard. That's one interface that will use that. And in many cases, what we're expecting is that for the 1 inch, a lot of people will use some sort of a disconnect in accordance with, there's a white paper on disconnects that was published. So that's kind of where we're at. We're just trying to make it so that actually simplify the project for providers, if you will.
I don't understand why the pressure here and the push here. In my opinion, it doesn't make any sense because the plumbing industry and the HVAC industry, particularly in the US and probably in the UK, are mostly non-metric. So, and when you get components and when you get pricing and availability, et cetera, you want to make it as simple and easy as getting the components, et cetera. If you put a limitation like the metric thing, all of a sudden you're creating a barrier. And your goal, as you said in one of the slides, and your goal is to eliminate the barrier. So,
well, one of the points that Don made, that the only reason I haven't objected to it is it's not a barrier or a requirement, it's a recommendation. So this is the path that we would like to move forward to within reasonable and within our ability to do so, right? If there's a way, if we can choose between metric and something else, then we would like to go to metric because that's the path that we want to go to. But nobody wants to double their budget in fittings because they can't get them in metric and they can only get the national standard or whatever. So with that, recommendation specification, I think that's what I'm comfortable with. If we say, hey, it has to be metric, then at that point, I don't think it's reasonable. But that's not what we're saying. It's just this is where we want to move forward in hopefully the near future, as allowed by material availability and other factors.
I just want to add to that as well, if you don't mind. UK is largely moved over to the metric system already. That's been a couple of years ago already. It's for all the other regions in the world. OCP is aimed to be a global platform, and the only region in the world where the metric is still dominant, it's the United States. But the whole rest of the planet is completely metric, right? So what we have decided within ACS is that we will only use the metric system in all the specs and documentation. But there's nothing against anyone making a choice for imperial standards or different systems altogether. But the documentation in our case is fully focused on metric. That's the basis.
I appreciate the discussion. I'd like to take this discussion off the table for right now, but what I would like to do is, Dale and Shlomo, if you have actual people that say, this is going to inconvenience my world if this recommendation comes out, let me have them contact us, okay? Have them show up at these calls, have them give some input. If there's people that will say, actually having a metric thread on the immersion tank is going to be an inconvenience for our ability to deliver liquid cooling, have them join the call. What I appreciate the potential concern. I really like to hear from people that actually would say this would screw up my job. Okay.
I think that the threads that you're talking about, your metric or non-metric, my opinion, in the whole issue of liquid cooling at the moment, relative to what this committee is trying to accomplish, I think it's a secondary issue. I think there are bigger issues that you need to resolve, and you don't have.
Absolutely. No, Shlomo, I do want to say that I definitely want to get, because we've actually hashed about this a fair amount. It is a secondary issue. So let's go on to something we want to talk about today. I don't mean to cut you off, but this is a topic that was covered extensively in the past. And what I'd like to get to today is what we were planning on talking about today. Are you okay with that?
You got to focus on the important subjects, and I think you're trying to do the right thing.
Absolutely. So let's kind of go back to a topic that came out and actually got a lot of attention at the 7x24 meeting last week. And that is the concept of risk versus mythology, or mythology versus science, okay? And so last week, for those that weren't available to participate, there was a 7x24 conference down in San Antonio, and the OCP Advanced Cooling Facility had a panel discussion featuring John Gross, John Musili, and Valerie Sorrell. I facilitated that, and we kind of ran through some topics. And the general theme that kind of comes out that that I want to talk about today and keep going forward is applying science rather than mythology on heard it from a friend, who heard it from a friend, who heard it from a friend, you were leaking around. And no, I'm not going to sing that today, okay? Sorry, Valley. But the general theme is when we at the, I did hear in the hallways a certain number of people who said, I am never going to put pipe above my racks, period. Any thoughts on that? You people know guys that say they're never going to put. So today's discussion, what we're really looking at here, overcoming your fear of pipes, bust myths using science. And some of you may have seen, I posted this on here. This picture over to the right, anybody recognize what that picture is? The color should give it away.
Yeah, I guess that's Google.
It's a Google data center, and I don't know exactly what's going to go underneath those pipes, but one thing I do notice about those pipes is what? Well, besides colors, what else do you notice about those pipes?
Is this where you're waiting for somebody to say they're running overhead?
They're running overhead, and they are solid all the way through. And that is one solution you can have. If you're going to have a pipe run over your IT racks, and I'm assuming this room is going to be populated with IT racks. It looks like it might be. I don't know that for certain. I'm just taking some guess. But the concept ends up being, if you're with a slab floor, which is what we're focusing on today, is the addition of liquids in a slab floor environment. If you're going to add liquids, the pipes are going to go overhead. Over to the left, you actually have a data center where the pipes are overhead in a slab floor environment as a retrofit, okay? And that wasn't quite as clean and everything else, but the courage, and by the way, there's other shots, but I don't want to show too much of this company's data center, has these right next to IT racks, okay? This pipe jump, don't fear liquid cooling, plan for IT, plan for it. How do you make that lump? How do you decide if you use this wonderful world that we talked about before? Scrolling down here. Failure mode effect and analysis. Okay. What you have here, failure mode effect and analysis. First, you have to detect or define what your failure mode could be. You assign risk factors, severity, probability, detection. You mitigate risk factors by optimizing design, increasing MTBF, improving detection methods, okay? Or by procedures, as in, well, let me kind of say this. one of the I'm going to ping on Cool IT or Rolf. The process of disconnecting or connecting a liquid cooled IT, is there always going to be a certain potential of dripping or leaking something?
Yeah, in my opinion, there is. At least you have to be prepared for that. But
Okay.
I'm looking at the larger units. I'm not talking about server connections. I'm not talking about the distribution header as part of the rack. I'm talking about main manifolds, right? So that's where you're gonna have slight pipe drainage because there's no the cost involved with doing a valve on top of a valve or a dripless connect for 1 inch and higher, or 1.5 inch or 2-inch pipes. That's heavy costs incurred. So having a spillage of a couple of centiliters is usually something that's common when you're disconnecting a pipe.
Okay. So how do you get around? How do you reduce the risk in that environment? How do you take away the risk factor?
Well, you're not doing that at the physical location of the IT equipment. So when you're talking about immersion tanks, those connection points should be outside the fluid area, outside the server domain. So it means that you can some basic as well. Let's just call it. Let's bring a towel. You know, there's going to be a couple drops on the floor, probably, and that's something that you can wipe down. But you're not doing that on top of a rack, not above a rack.
So in the Navy, we refer to that as a SOP or an MOP. Okay. Actually, in the Navy, we didn't use MOPs. We just held everything in SOP. And SOP was a standard operating procedure. And you had a checklist. And so you identified a couple of things there, Rolf. First off, you make the design so the risk factor is in a location that is of minimal direct risk. You reduce the severity factor of the potential of leakage. And you also, you quantify how much leakage you could get. If you're just taking apart a hose, you shut off 2 isolation valves. The maximum quantity leakage you can get from a isolated piece of pipe is the volume of the pipe. Okay, and you have a procedure where you open the drain and you would see if you fully drain the pipe, and if for some reason it looks like the isolation valves aren't holding, then you would stop the process and you would contain the risk. And that's called, you can't get a perfect design, so you use MOPs, SOPs, and the design puts the risky operation in a safe location. You don't put the valves right over your IT racks. But then the MOPs and SOPs and commissioning, we're going to talk a little about commissioning is the other aspect. What happens, how do you, what we saw before was a solid piece of pipe, and we saw another pipe that had connectors on it. But one of the questions that also came up at 7x24 was, what about using this kind of pipe? Okay, how do we decide what we're going to do? And this is where I start looking at this term, looking at FMEA of pipe connections. Okay, is there a method to, well, we'll start with wells. Do wells ever leak? Question. Anybody? I'm going to sit here until someone says yes. Well, so let me say this. Do wells on a submarine ever leak? The answer is they don't leak on a submarine because we radiography 100% of our wells, okay? But if you actually, and I can show this and stuff like here, so one method here is if you do radiography as part of your commissioning, and radiography, and there's 2 different modes of failure I'm looking at here. One is leakage, the other is separation. We'll call it separation. So if you use radiography, if you had a welded pipe with radiography on it, would you be comfortable with that running over your pipe racks?
I think this is John. I think the short answer is yes, right? There's a lot of belts and suspenders involved in that.
Okay, and I'd love that. I see there's a couple MEPs, other MEPs on this call. Would love to hear from them, speak up on that. But so that could be, if you're actually looking at the highest level of severity, the question of running a pipe directly over your IT rack, that may be one way to use. The severity factor is still huge. A pipe separation above your rack is what we call a very bad day. However, if you can reduce the probability to where it's not really an issue, then you're back to what we saw in this picture here, which is people running reasonably large pipes over IT areas with acceptable levels of risk. So we'll go back down to that little drawing we had before.
So Don, this is John. I think the gap in this is, and I was thinking about how I was designing around the world. When you were in, we really had to assign seismic zones to this. So this another column in this for pipe. With pipe, a lot of failures for separation and or major leaks will take place during a seismic event. And that was always the most difficult thing to manage, was what's the response in a seismic event? Because right, the seismic event essentially it does have an outer bounds, but for whatever reason we keep getting to it in some areas, and of course the stabilities. So anyway, the seismic was always a risk in the pipe and routing protocols in seismic zones.
Seismic also, and I'd also tell you the same thing in a submarine. You not just have a little bit of shock here, a little bit of shock there, but if you go deep in a submarine, your submarine actually gets smaller. We used to tie a rope from one side of the submarine to the other side of the submarine, and we'd make it really rigid. And when it went down a couple hundred feet, it would sag. Okay, and if it sagged, all the pipes were kind of doing that. So there's a certain amount of movement that's happening, a certain amount of stress. I would say our welded pipes never leaked, but we did have some issues with how do you commission a flange? Okay, would you put a flange above your IT rack?
Hey Don, real quick, we've got radiography there as a detection method for detecting leakage for a weld, for example. But I think on many of these connections, we can't leave out the simple methods that people would use, the normal, pressure testing with a gas, pressure testing with a liquid. These are more common outside of, let's say, the military industrial complex or nuclear, where radiography gets done.
Great discussion. Now let me kind of break that. Does someone want to comment on that?
Dan, why aren't you or are you separating between what I will call the liquid loops, which is where the operations are happening, and the data center loops? Are you separating, or are you assuming the same type of technology and application in the main loops in a data center, which are primarily water? Or are you trying to make a generic type of system?
Shlomo, let's kind of go back to what our charter here is. We started out with the discussion that we assume that people have been making reliable pipe solutions to go around the outside of their data center, and we're not touching the FWS solution. We're not actually, what we are looking at is what would you do when you get put pipes in the highest risk factor, severity factor area of your data center, okay? So that's the key question. What will give you the confidence to run a piece of pipe above your IT rack, which is what's going to happen here, which is different. I know that Dale can talk to me all kinds of solutions that they've done, and so can a lot of you, on solutions that have been done on FWS. I'm specifically asking for the highest level of risk factor, putting it right above your IT racks. What is acceptable?
Well, I don't want to put a can of worms here, but what I consider acceptable is a negative pressure system. But we're not going to talk about it today.
That's a great highlight. And negative pressure is something that is, I'll add to this list. as being, well, let me say this. What we could do is, this is just something I kind of came up with on a scratch here. And what you're looking at here is, to the point, if you're just using pressure, you're not using radiography, do you have confidence that you'll never have a weld leak? Is anyone on this call comfortable that if they never did, that a weld is not going to leak if you haven't radiographied it? I went to a
Don, I brought up the idea of the pressure versus the radiography, and the answer for me is no. I mean, it's definitely a commissioning issue, in that we would be typically comfortable with pressure on day one, depending what the system is. If it was a refrigerant, for example, we might use a smaller molecule than the refrigerant, like hydrogen or helium. Helium, usually to get really, to see if there's any seepage. But, you know, on a longer term, a weld that is just good enough can easily corrode, right? Corrode and or be worn out by crack corrosion, you know, in the flow. So I would say no, it's definitely not as good as radiography.
Well, so again, what I would say is life to pipe confidence. And I will also tell you there's some great welders out there. I went to a data center owner up in Canada one time and I said, who do you use for welding? And he said, Mario. Not Mario Conti, but he said, Mario. And I go, Mario? And he goes, yeah, Mario. And I go, what if Mario's not available? He goes, then I won't weld. Okay. Now, I also will say that from the Navy's perspective, when you get the highest level of mission critical, you do radiography. So the question ends up being, what do we, I guess the thing is, one of the problems we have is MTBF data is fantastic, but anyone know why we don't get MTBF on welds? Mean time between failure or mean time to failure data?
I don't know why you're using MTBF, period. MTBF has to do with electronic failure. It has nothing to do with mechanical failure. You're using the wrong terminology. Okay. This is MTBF. Hear me out. MTBF is a statistical.
Why do you say it's electronic versus MTBF works with any manufactured product that has the ability to can be electrical, it can be anything else, but if you go through the science, if you have something that's a very repeatable process that you can go through and you can drive out the defects, you talk about relative science, and the fundamental thing that you're really saying today is that you don't use it on weld because weld is artwork and much of pipe is artwork, and that's why you can't use MTBF.
MTBF is a random failure rate, and it's a specific statistical meaning. And people tend to take MTBF and try to put into the mechanical stuff, which is totally incorrect and totally misleading. So you got to be very careful.
Why is it incorrect?
Huh?
Why is it incorrect?
Because how do you figure out the random failure rate with a weld? You need to have a statistical way of figuring it out.
Exactly, Shlomo. That's exactly what, and I appreciate that. That's what I was trying to highlight here, is you cannot apply MTBF to welds because welds are artwork.
I don't think.
So we'll just put does not apply.
That does not apply, correct, in any of those.
So let's go on to flanges. How do we commission a flange? How do you know that a flange, would you put a flange over your IT racks?
I don't think you want to put any connection point above your IT rack, regardless of the shape or form.
Well, so.
I mean, not directly above it. You can put it close by, but not directly above it.
So one of the things that see if I can find this here. Let's kind of go through. I lost that little stream there. The short answer is, I went online, you look at what the commissioning process is for flanges, and anyone want to describe what it takes to commission a flange, or why a flange? Well, first off, do you see a flange having a separation potential?
Yes.
John?
Yeah, that would be wrong. When you see flange separations, there could be issues upstream as far as materials, or the material was cast incorrectly or made incorrectly, and it buckles, and or the bolts separate through a high pressure hammer, or wrong bolts are used, something similar to that, or seismic.
Okay. Well, so there is some, but to a large extent, if it's properly...
It takes a major event. Mostly it's going to be around poor materials or workmanship.
Okay. I guess the question I would say is, and back to the question, would you put any connections above your IT rack, or maybe in the overhead? And the question ends up being maybe not just above you directly, but somewhere in your room you're going to be doing it. Okay.
So let's
somewhere
talk
you have to.
I've been thinking through this, John, as we're talking. This is John. So the question is, would you put something, a connection above an IT rack? The answer may very well be yes, because that rack's not as important as another rack. The high level question is, would you put a connection over your critical facility, your critical infrastructure? Because some systems, there may be 100 servers or 1,000 servers or 10,000 servers doing the same job, and if you lost that rack, it's no big deal. But if that's the rack that manages assigning the jobs to all those servers, for example, something that's a critical path in your application, then you may not put the rack under that connection. But I don't know if we can say there's a prohibition of putting a connection over a rack. It's really how important is the rack.
Fair summary. Or the other thing you could also do is, if you had a connection over the IT rack, other things you could do would be add the leak protection, the design. You may put a tray there. You may put something, if you assume that it's going to be less than a full failure, you may actually put a leak detection rope there.
Right. And
does that make sense?
When you're managing your SOPs, put enough capacity on that tray or whatever it is to manage the flow of whatever, if you're just talking about not separation, full separation, but the max amount of fluid that could come out of that drop, for example, with a 3-foot drop, 6 inches in diameter, whatever the volume of that is.
Okay. And so the thing you will say, if you go online, you look at how to commission a flange or how to install a flange, you'll see it has a fairly detailed step. Number one, you do a bolt rotation pattern. You fully load the flange. You come back 4 hours later, because you have a certain amount of plastic seating on the or plastic deformation in the gasket, and so you retorque it then. And then anytime you have a issue where you think there's pipe movement or has been pipe movement, you may have to go back and retorque. And on board ship, that was we would pull into shipyards or pull back into the port, and we would end up connecting. But to your point, we never had flanges right over things that would leak or where leakage would cause damage. And if you did have flanges over things that caused damage, then you put some sort of trays and leak detectors and other stuff to make sure that the minor amount of leakage to flange. What I'm highlighting here is flanges can be very reliable, but they can be a big challenge if you don't contain them. Does that sound consistent with what you're saying, John?
Yeah, that's exactly the point. I mean, some of this has to do with engineering and risk management, right? You got to manage the risk, because exactly that at some point that flange may need maintenance, and you're going to have some drip off that line. So there's got to be some liquid management, however you're going to do it, whether it's ounces or gallons or barrels. It really goes to being smart about where you put it.
Okay. One of the questions that's come up lately, and that was debated, and I see in some discussions, is the use of fused connections. How do you verify that a fused connection is properly done? Shlomo?
I didn't hear you.
How do you verify a fused connection is properly connected?
I don't think that it's that simple. So I really think that all what we're doing here, we are trying to get to an area that very few of us in this, I believe, in this meeting have expertise. And that is plumbing, if you want to call it high-tech. I don't know if it's high-tech, but I'll call it plumbing. And I think very few of us here are really experts in plumbing. We know how to design a system, but we're not necessarily experts in all the issues that you're bringing up here. So it's not clear to me that this is the right place to address some of those issues.
So this is great, and this is the introductory discussion. I will have technical deep dives on this discussion in the future. In the meantime, I don't know if Rich Donaldson is on actually at his thing, but Rich Donaldson is somebody I'd consider a technical expert in this, as well as I would John Masilli on this topic, and Valley Sorrell dropped off, and Tom Swillow. They are all technical experts in these things that I'm talking about, okay? Now, one thing I can't tell is whether or not they're actually on the call or if they're just actually on the call and whatever. But, Rich, I see you clicked off there. Do you have anything you want to say? Rich? Your mic went off mute. I'm thinking you might be there. Are you comfortable in chatting now, or should we carry this another time?
I'm going to, unless Rich starts speaking, I'm going to add a couple things that I think might be missing from this list too. And maybe we include them on the list. For example, one of the things I'd mentioned, and I'm sure will come up for some people that are implementing liquid cooling, is whether or not to use push style connections, especially with small copper and some of the stainless steel ones that are available as well. You know, the shark bite kind of started or was well known in this industry, right? Now, you see them in houses sometimes or what have you, but, you know, we probably should talk or make a recommendation on that. And I'll also add one last one, which is something I've used in the past, and I don't know, you also might see if you hire a contractor to come in and do some of your piping for you, which is, I would say these are not crimped connections in the normal sense of a swage, like you would use on a high pressure system, like a, you know, hydraulic fluid, but low pressure compression systems. Viega comes to mind as one. These are where you go around your copper or a stainless pipe with a set of crimps, and it crushes the housing around an O-ring or some other kind of a sealing mechanism. But I think they should be included, and we should at least weigh in on them so that users can get a feel for what we think about them. You know, what this group and the expertise here thinks about them.
So I guess the only question I would ask, we're primarily talking about connections that are over 1 inch in diameter. Do you see a lot of push types done on over than 1 inch diameter?
No, I don't. But I'll tell you that the crush crimp style, I do see. You see that? I see it more and more. I just went into some friends are building some houses, and all of the copper that was done with that type of connection. Everything else was PEX, and the compression style fittings were used on all of the copper. So it's not a stretch to think that somebody's going to encounter this when they're dealing with liquid cooling in the data center.
And
that's true.
Yeah, that kind of makes sense in that. And I see the application for the crimp because you don't want to bring heat into your PEX environment. Somebody's going to screw up. That would make a lot of sense in that. The question is, what's the what's I'm familiar with those systems, John, not maybe specific to the ones you're talking about. It makes sense in the housing side, and it could here also. There's nothing wrong with that. It's really going to go to what's their mean time to failure in casual or non-factory installation. The problems I've had in these crimp styles is the mandrel and or the user and or the pressure settings have been wrong. So it's really an assembly issue and testing issue more than failure when properly installed.
Sure. And so that's good. So I think that's something we should capture here, Don, is that, those types of connections, like John said, that they are some of the variables that can influence whether or not it's a successful installation on day 1 and on day 1000 are mandrels, pressure, etc.
But I do like it because the good news is you don't have to flame or open flame or heat in those space.
Yeah. No, there's definitely a big advantage to it. You can get you can go up to, I actually don't know what the high level on them, but I know at least up to 6 inches is available in some of these. And, what's pushing people to do it is the same reason you use couplings. No need to have a torch or in a data center. And so anyhow, I think it's worth us addressing as a group, because I bet you it's going to come up.
Yeah, I used a similar design. I did not install it. The project did not go ahead, but it was a PEX going up to 6 inch, and using I was cooling radiators off of generators with it in the building that were stacked. And what I did in the way I ran PEX or welded systems like this was you get, I can't remember the numbers now, I think up to 400 feet on one reel, maybe you get bigger. But anyway, when I ran through my critical spaces, I didn't have any welds in my critical space. I put them all out in the utility shaft, which was drained, kind of like a big elevator shaft, so that all my connections on welded connections were out, one where they could be observed, and 2, they failed partially or catastrophically, I had solid paths over my critical equipment and kind of went into this waste zone otherwise. So essentially had the longest run good working around the critical equipment.
So we're out of time now. This is a topic area that I think truly needs to be addressed and continued to discuss through as we're doing right now. And the key thing we really need to figure out in my mind is if it's going to be somewhere in the elevated position, be it over the racks or somewhere higher in the room, then we need to have some sort of method that verifies it's not going to leak, or you need to prescribe leak detection. Okay, so we we achieved the fact that radiography welds would meet that requirement. Solid pipe would meet that requirement if you're putting it somewhere in the high risk area. Then the next question ends up being, are there others? And we didn't get too much on fuse connection. I'm still interested on how I have worked with PEX, and John and I both share a background where we at one time sold solutions that had PEX pipe, but it was generally a smaller diameter PEX. What was it, about 1.25 inches, John?
Yeah. It was 1.25 inches. It was 1.25 inches. Yeah.
I'm just kind of guessing from memory.
And by the way, that's another topic, because that was known as PEX Alpex. It's a PEX with an embedded layer of aluminum in it. Very strong stuff. We were doing home runs versus doing a radial distribution, which is another whole topic, right? What's better? The number of joints certainly decreased, and they were crimped style joints at the ends. So we effectively had only 2 locations where we had crimps, and then those terminated onto threads. And then the thread connections were US style thread connections. But it's another good point.
I'd like to try to do a technical deep dive on this in the coming weeks on maybe the Wednesday session, try to get people that are comfortable in saying that they are pipe experts and things of that nature. Because there are, contrary to Shlomo, there are ways of doing MTBF on some type of connectors that have been very successful. But if you don't have it's one of those things, that's where FMEA applies. If you think there's a potential for a leak, then you put leak detection, you put trays underneath, or you just don't put it in the high risk area. And so that's kind of where we're driving through. I'd like to continue this discussion. Any final comments before I take this off record?
Don, thank you. I'm going to have to go I'm overdoing it.